Welcome attendees and our chair on this call, Andrew. Today we are joined by fellow workgroup members and contributors to the Blockchain for Hospitality white paper, which is available on htng.org. Would our workgroup chair please introduce today's presenters for this webinar on how to build a blockchain?
Certainly, and thank you, David. It's my pleasure to introduce three gentlemen today, all from various parts of the world and all from NTT Data Services. Chrestman is Commercial Industries Advisory Leader, and he's based in Atlanta. Suresh Balasundaram is Blockchain Practice Leader for NTT Data Services, based in Dallas. And Harsha Kodlaya is a Blockchain Technical Architect, and he's joining us today from Bangalore in India. Now, as many of you will know, this is part of a series of webinars on the topic of blockchain for hospitality, and it assumes a certain prior knowledge of terms and concepts and will be fairly technical. So if any listeners would like, they can get access to prior webinars via htng.org. I think this will be a very interesting webinar, especially as Harsha will be showing a live demo later on. So I'll pass over to Criss now to start. Criss, over to you.
Great. As mentioned, this webinar picks up where the blockchain white paper and other webinars left off. Hopefully you've had a chance to look at the white paper. We have only 10 slides here, since most of our time will be spent demonstrating the application and the code behind. So definitely not a death by PowerPoint presentation. But we do have a few slides to cover. So first, we will talk about how we use the white paper as guidance to select an application and platform for this demo. And by the way, the white paper has good similarity with our own NTT data framework, so really good fit there. Then Harsha and Suresh from our blockchain practice will demonstrate the code we're going to show you for Know Your Customer application, developed for the banking industry, but with applicability across industries, and of course, including hospitality. So where the white paper left off, we'll start with a hypothetical getting started scenario using, as I said, the white paper guidance for the approach. On the screen now, you'll see a summary of chapter 13 from the white paper with a cross-reference to the different white paper chapters that provide more detail and elaboration of that particular step. This is a nice framework to use. Like I said, has some in common with some of the aspects of our framework. While this table is inferred in the white paper, it's not specifically detailed to this extent. So you may want to pause. If you go back and look and you need this cross-reference table, you can pause the recorded webinar here and go through these steps. To expedite the webinar, we'll qualify the blockchain candidate with just 2 steps that I've indicated in the gray bar to the left. We're going to identify a candidate application using use cases we have from our NTT data engagement portfolio. We're going to then qualify the candidate in terms of what value blockchain can add and what platforms applicable. So that'll help narrow get us to that point. On the left hand of your screen are the top 6 use cases I pulled from our NTT engagement portfolio of about 100 engagements. Note that almost all these are private or consortial blockchains, mainly from banking, insurance, healthcare, manufacturing, and logistics. In the right-hand column are hospitality comparable use cases. Many of them are really talks we're currently having with our travel and hospitality business, or in some cases, ones I picked up from Hedda a few weeks ago in Los Angeles. I'm sure we'll be discussing these and many like these at HT Next in April. So since there's already been a webinar on use cases that I highly recommend, I will not dwell on these, but instead use my allocated upfront 5-minute time here to direct your attention to a couple of things. The first being number 5 on the list, which I've highlighted, and this is the one we're going to demo. Know your customer, cross-industry applicability. The second thing I want to highlight on this screen is I noticed in our engagements, the most common themes that seem to be most consistently in demand, and therefore perhaps the most practical in speaking today's world for blockchain, are secure document sharing, Internet of Things, and financial transaction orientation. Another point here, and a plug for HT Next in April, here in a few weeks, we're looking to feature number 6, Smart City, at our booth at HT Next, a diorama for that. So it's pretty cool. So now that we've selected the Know Your Customer application developed for the banking industry, I want to qualify that's a good candidate and what is the best platform. To net it out, it's a good candidate just because it's process improvement. It makes it easier to do business with us. A keynote speaker had a great tagline: "Convenience is the new loyalty." I think any way we can do to get to know our customers better and expedite processes, such as another work group, bypass the front desk, is valuable. Suresh, is it okay here if you elaborate on the platform criteria?
Sure. Typically, what it involves is understanding the business process and taking out the requirements from it in terms of whether it's just B2B or B2C, or it's a hybrid approach involving both B2B and B2C in the same process flow, and additional security and privacy requirements, how you want to integrate it with your existing enterprise applications at the back end. Taking into considerations of all that, it's recommended to follow a framework of evaluation. And the evaluation is in 2 steps. The first step is whether the business process itself is a right candidate for blockchain. And we have a set of questions to answer and a set of parameters to validate to identify that. As a second step, to identify the right platform, and as you know, with the eruption of crypto market, there are about 300 platforms out there which are open source. And additionally, there are frameworks from large players like SAP, Oracle, and Microsoft. So it's quite overwhelming that you have a number of options to build it out. So the second step is to evaluate what would be the right platform, taking into the business process, the requirements, and how you want to integrate it. That gives us the answer for right blockchain platform and the right business process to be built on it. And then it follows with the detailed solutioning and development.
So one more point, Suresh, before I turn it back over to you for your application demo. I just wanted to show that your teams, the practice NTT data credentials, and the left 2 images are purposely obfuscated, just kind of showing the credentials, why it makes sense for Suresh. Headliner is that our practice is finished in the top 3 analyst ratings in their top category. And on the right-hand side, I also found it interesting the platforms for our 100 or so blockchain engagements are the most common used. I believe this is still a trend, although there's a lot of, just as with the use cases, there's a lot of one-off, but these are the most common ones I saw in our portfolio. Suresh, back to you if there's nothing you have to add on this.
Yeah, just a bit on the platforms here. As I mentioned, there are about 300 plus platforms. The analyst groups have ranked these platforms in terms of their maturity and readiness for the enterprise adoption. So primarily we focus on the top 5 platforms, and the analyst rankings are for the top 10. So we pick the top 5 out of that, which are mature enough to build enterprise grade blockchain. And we also explore in terms of implementing those platforms as a backend on SAP's framework or the Oracle's framework, if your existing enterprise landscape is SAP or Oracle. All right, so coming to the solution here, we picked KYC because it's one common process across the industries, very similar to the payment process. or identity management or asset management. KYC is a part of the customer onboarding process in a B2C scenario. Even if you are looking at a B2B scenario, you can do a vendor onboarding with the same kind of steps here. So referring to the picture on the top, so what we typically see is as a customer, we go into an institution, submit our identity documents as scanned copies, and the institution verifies that with the legal or the regulatory databases and approves it, and we are compliant with the KYC requirements. And when we move to the second business, we do the same stuff again. We submit the whole set of documents and again wait for them to verify and approve it. Now, this is highly redundant in terms of repeating the same process with every other institution that we work with. And as per the market statistics, it takes about 12 days in the retail banking segment, and it's about 37 days for large corporations to get their KYC done. This leads to a poor customer experience. It's like you're repeating the same process over and over again. And from an IT landscape side, it's multiple systems of record. And once you submit the documents as a customer, we don't have control over it on where it is being shared and how it's being handled, leading to identity thefts and all that. Now, how blockchain can help in this scenario is the picture below. As a customer, we can submit documents once to a trusted party. That is, it could be a regulator, a government entity, a large business, a large bank. And the KYC personnel within the institution manually verify that, checking the databases. And once they do that, they issue a crypto token, which is an identity, a digital identity for the customer, which is in control with the customer. Now, once the customer receives that, he has the liberty to selectively share the information with other institutions to be KYC compliant. Now, this is a one-step process, a one-time verification for token creation. And once you receive the token, you can use that and share it with as many parties as required, as long as they are part of the network. Now, this takes just a couple of minutes for them to be KYC compliant. And it's highly secure, highly efficient, and compliant with any auditing and regulatory requirements. And you know that you are in complete control of your data, and there's no way it can be misused. Now, so what I have here is a set of screens in terms of wireframes, just to demonstrate the flow here. We have taken out some customer-specific or very business-specific fields and data out of this. So this is a pre-populated screen just to show how the process is simple. And this is a clickable demo here. I'll just go ahead and click that. So you have three different participants here. The first one is a customer who submits the documents. Second is an auditor who verifies all the documents and approves them. And the third is a new institution, a business partner who gets the KYC done. So first, let's look at the customer. He logs in with his own user credentials. Initially, his KYC status is that he has not submitted it. He goes ahead, enters all his information here, uploads the necessary files, right from photograph, the driver's license, passport, utility bills, and he submits that. And once he does, the status is under review. Now, the request has been submitted to the auditor in the primary business entity. It could be a government institution or a large bank. And what really happens here at the back end is once a customer uploads the documents, and we know that blockchain is for typically transactions, and these documents could be large data sets. So we bring in the concept of an integrated distributed file storage, which works similar to a blockchain concept. And these documents get stored in a distributed file storage, and the location of these files are, again, not a single source. It's distributed, and those location information is being integrated within the blockchain transaction that gets recorded on the blockchain network. So they can be sure enough that the documents are secure. Now, once a request has been submitted to the auditor, they log in, they see a couple of requests that have come in. They pick on John's request here, verify all that information. This could be with system integrated APIs, or it could be manual verification. Once they verify it, approve it, enter their comments, and submit them. Now, coming back to the customer's login, he'll see that his status has been approved. Now, he has been issued that crypto token. It's all happening at the back end. From a user experience standpoint, he just sees this dashboard which shows the status. Now, he can go ahead and share that token with the other business. So he click on share. He has a token ID here. Now he picks a list of pre-registered participants here. This could be a utility company, a car rental company, an insurance, a hotel, banks. In this case, I picked Union Bank of California. If he's at the customer's location already, he can scan the QR code. But if he's doing it online, he can initiate a token share. The token share has been initiated. Now let's move on to the partner's screen. The partner logs in, sees that there is a token share initiated. Clicking on that, we'll see that the request has come in. Now, just to ensure that this has come from the real person, not initiated by a bot, they can post a security question here. So in this case, let's go for last 4 digits of the national ID and post a challenge question. Now, coming back to the customer, they receive the question, enter the information here, and authorize the token share at this point. And on their dashboard, they see where they have shared it, and you can also have a timeline defined on how long the information should be shared. And you can also show that how many days remaining you have on that token share. Now, from a partner's perspective, once they receive the authorization for the token, they can verify the specific information they want to look into and verify it, and it's completed. So it's as simple as that. You can customize it with more business requirements around this, and very specific process flows built into the process. And all the validations, approvals are being taken care with a smart contract behind. Pass the baton to Harsha to look into the live demo and system internals.
Hello, everyone. My name is Harsha Kodlaya, and I'm part of the blockchain team at Entity Data. Today, I would like to demonstrate setting up of private Ethereum blockchain and IPFS storage networks. Next, we will be deploying smart contracts onto the Ethereum node using Truffle framework. And finally, we will interact with the blockchain node from the KYC application and witness the creation of transactions and blocks as we navigate through the application. Now, before going to the demonstration, let's take a quick look at the reference architecture of a standalone blockchain application, such as the KYC application that was previously demonstrated. On the right-hand side, we see an Ethereum virtual machine running on a client such as Go Ethereum. Now, this EVM, as we call it, allows us to interact with the underlying blockchain ledger, manage user accounts, run transactions and manage logs of such transactions, provide mining and consensus mechanisms, facilitate peer-to-peer communication, and also store and execute smart contracts and the Ethereum state. Right? Now, blockchains are primarily transaction recording technologies, and storing large quantities of data often come at monetary and performance costs. So it is a good practice to have some kind of off-chain storage mechanisms deployed alongside a blockchain network. Now, off-chain databases, as we call them, store any static or large data entities such as customer or reservation details, and only a reference to these entities are stored on the blockchain. Now, the state changes of these entities as they happen in a larger business process where multiple parties, multiple organizations are involved, are tracked on the blockchain for everybody to see. Now, here, MongoDB is only representational. It could be any RDBMS or NoSQL technologies, or even enterprise or ERP databases if the blockchain is being integrated with existing enterprise systems. This database may store any proprietary information that is not intended to be shared with other participant organizations, right? Maybe other parties don't need to know the details of a hotel reservation or a customer's PII information. So such data can reside in one of the off-chain databases. Now, there is also a distributed file storage system called Interplanetary File System, or IPFS, which is used to store large objects such as documents or even small JSON objects. IPFS is like blockchain. It's a peer-to-peer network, and it is focused on storing and distributing content in a decentralized manner. IPFS integrates pretty well with blockchain in a way that the IPFS file addresses may be stored in the blockchain storage for easy mapping with the entities and later retrieval. In essence, any off-chain data that may be required to be shared with other participant organizations in a consortium network, may be stored on the IPFS, and any proprietary data may be stored on on-premises data stored like in a MongoDB. Now, next is the API layer, and this layer may be built using any of the mainstream technologies such as Java, Python, or Node.js. This API layer may contain business logic or integration components in a larger enterprise systems. If you're trying to integrate with an existing ERP or a CRM applications, we can use integrators to integrate with the blockchain node. Now the API layer may be built using latest architectural practices such as microservices, and typically expose REST APIs with JSON as the data exchange format. The API layer also involves JavaScript-based blockchain and storage access APIs for Ethereum and IPFS, which allow us to interact via HTTP RPC, remote procedure call protocols. Now, the presentation layer may be one or more web applications or mobile applications that every company in a consortium may choose to deploy. And these applications interact with the API layer via the REST API gateways. In cases where blockchain is integrated with enterprise applications, the user may interact with the existing application's user interface and have the events and information exchanged with the underlying blockchain. It is also not uncommon to have an administrative dashboard to monitor blockchain activities such as transaction load, user accounts, network loads, and any not normal activities going on the network. Now, moving on to the typical technology stack used in building a standalone Ethereum application such as ours. At the very bottom is the cloud-based hosting platform such as Microsoft Azure or Amazon Web Services. Most cloud providers today provide package templates to quickly spin up nodes for popular blockchain technologies like Ethereum or Hyperledger Fabric. The Ethereum cluster of nodes are typically hosted on Ubuntu virtual machines using Docker containers with appropriate network security and load balancing configurations. In a consortium network, each participant organization may use their own hosting modes, maybe cloud or on-premises, as dictated by their IT policies. As long as these nodes can talk to each other, we'll have a working network. Going on to the next layer, which is the blockchain distributed ledger, the blockchain platform used here is Ethereum, enabled by Go Ethereum client, or in short, Get client. Solidity is the programming language used to develop smart contracts. Truffle is a development environment and testing framework for Ethereum. Truffle Suite makes Ethereum development easier by providing built-in smart contract compilation, linking, deployment, and binary management. And it also provides a development blockchain node called Ganache and a console to interact with this blockchain node. We'll be exploring more of Solidity and Truffle and Ganache in coming sections. Now, the storage is IPFS and MongoDB, as previously stated. This may be replaced with any other alternatives as per the architectural needs. Coming to integration, the API layer is primarily Node.js for this application with NPM as the package manager. Express.js and JSON are used to build REST APIs that may be invoked by the presentation layer. Now, Ethereum's Web3.js is a JavaScript API to interact with the blockchain node over RPC protocol. In addition, we also use Truffle contract package, which acts as a wrapper around the Web3.js APIs to provide a better Ethereum contract abstraction so that our application code may synchronously interact with Ethereum smart contracts. I'll be showing how to configure that in the coming sections too. Similarly, the IPFS.js provides JavaScript APIs to interact with the IPFS network, such as to upload and download the content and etc. Now, the distributed app is built using Meteor.js in this case, with Materialize providing the CSS. Now, let's see how we can create a private Ethereum network from scratch on our system. So we are on Ubuntu virtual machine. Let me open a terminal here on my machine. Now, as a prerequisite, we need to have download Go Ethereum. Yeah, the Go Ethereum client as instructed in this site. Once the Go Ethereum or Get client is installed, we can double check the installations by running the command get help. So yeah, so I have my Get client up and running, so I can proceed to the next steps. Now, before we start executing some commands, let's take a quick look at the directory where the data such as account key files, state database, and ledger data stores of our nodes will stay. So we're building a private Ethereum blockchain network of 2 nodes. So we see that there are 2 directories here to hold the as the data directories of those 2 nodes. Node 1 data is the directory of the first node, which is currently empty. Node 2 data is the directory of the second node, which is also currently empty. Now, we'll talk about the genesis.json in a minute. So the very first step, let me clear this. Okay, so the very first step in creating a private network is creating what is called an externally owned account. Now, Ethereum is an account-based blockchain where each participant needs to have what we call an externally owned account. This account has private and public keys associated with it. The participants of the network will have to sign every transaction with the private key of the account they're responsible for or the account they're using. The accounts have a 40-character or 20-byte address, which is derived from the hash of the account's public key. Now, also every smart contract has an account and is identified by the same 20-byte or 40-character address. But the smart contract's account does not have any private or public keys. It's derived basically from the public key of the creator that created the contract. So as a first step, let's run the command. I'm in my directory. I'm saying get account new data directory of node 1 data. So I'm actually setting up the node 1 right now. So it asks me for a passphrase. Oops. Let me try that again. It's taking a time. Okay, this passphrase is basically used to symmetrically encrypt the private key of the account. So whatever public and private key pair that was associated to the account is going to just symmetrically encrypt using the password. So any user signing the transaction has to provide his passphrase first, which will decrypt the private key, and then the client goes on to sign the transaction. Now let me show you the key store of the node 1. Now we see that there's a new directory called key store created here, and this is the first key. When I open it with file, I see that this is the address of the first account, and this is the ciphertext of the private key of the account. So it uses the encryption algorithm, and then it has symmetrically encrypted the account. So this is the address here. Now it is to be noted that these key files, so the key files in this directory need to be safeguarded by the owners, because without them the participants will be unable to post any transactions to the Ethereum blockchain. So it's the responsibility of every organization for the safekeeping of these keys. Now let's take a quick look at the genesis.json file. Now, to give you a background, a Genesis block is the very first block of the blockchain, of the Ethereum blockchain. And the genesis.json file contains information to create the Genesis block. The chain ID here identifies the current chain we are trying to set up. Now, keep in mind that some of the IDs are reserved, such as 1, which is the Ethereum public network, 2, 3, etc., being the Ethereum public test networks. So we can use any large number, a non-reserved number, to identify our network uniquely. So we've just given it as 5777. Now, a homestead block of 0 indicates that we will be using the homestead fork of Ethereum. There are different forks of Ethereum at this point. And the EIP 155 and 158 blocks being 0 indicate that we will not be using any of these forks. Now, Ethereum uses Ether as a currency to operate on the network and to reward the miners. Since it's a private network, we use what's called, it's a play money, right? So we can indicate, we can initiate the address that we just created with any amount of Ether that we need. So let me go back to the account that I just created, copy this address. I'm going to say paste. Just make sure that it's a hexadecimal address, right? So I just initiated this address with a balance of 1 gazillion ethers. Now, the address that we just created is also indicated as a Coinbase address, which is sort of a default address for the network where all the mining rewards go to. We set a very low difficulty for the proof of work because it's a private network and it doesn't really have to be incentivized. Now, gas is the fuel required to perform any state changing operation on Ethereum. So this is analogous to the gasoline used to run our vehicles. So we'll set the gas limit of 1 million for each block. So this essentially means that as a node receives enough transactions that totally amount to 1 million gas units, it can trigger the proof of work mining. Now, for 2 nodes to connect to the same blockchain network, they should have the same network ID and the same Genesis block configuration. So let me first save the genesis.json and then go back and initiate the first node by running this command. Okay. So what I did was I set the data directory as node1 data, init, and use genesis.json. So what it essentially did was create a Genesis block for this node. So I have an additional directory here called get, and we have directories called chain data, light chain data with all its state and ledger files created underneath it. Now let's go ahead and spin up the node, the first node. And we'll be running this command to do that. So again, get identity testnet, the network ID is 5777, it's the same ID that we gave in our Genesis block. This is the first node, so I'm giving the data directory as node1. The RPC protocol is enabled, so any application can reach this node via RPC protocol. And then RPC port is 8543. And the IPC port is 30301, and I'll set this as no discover, which means that no other nodes can automatically discover this particular node. And the IPC path is interprocess communication file. Now, when I run this, okay. So my first node is up and running. So please double check the chain ID here, which is 5777, and make sure that it's not connecting to the main Ethereum network. Now, let me go to the next window, a new window, and connect to the first node via the IPC. So I ran this command, and now I can interact with my first node. So let me run some commands here. Okay, I said, get me all the accounts in this node, and give me the account that we just created. And then let me check the balance of this account. It is at 1 gazillion ethers. Now I'm going to create an additional account like we did previously. And it's again asking me for a passphrase, and I just get the passphrase. If I go back to the key store, I should see that, yeah, it connected a second account with this address. Now, let me see the Coinbase address of this node, and it is the first account that we created. All set, and then is the node mining false? So we just intentionally left it turned off as of now until we get up the second node. Now let me also check is there any other peers connected to this, and it returned an empty array, which means there are no other peers connected to this node. Now let me go back quickly and create the second node. Now all the steps that I just performed can be done using a batch script. So I just did it by running individual commands, but this can be the node can be brought up by just in a few seconds by running a batch script. So I created the second. I'm initiating the second node. Please note that the data directory is node2 data, and I'm using the same genesis.json file, because if two nodes have to connect to each other, they have to have the same genesis block or the blocks of the same configuration. Now I'll use a similar command to get the second node up and running. So the change here is that I've changed the data directory to node2 data, and the port it's listening to is 30302, and the RPC port is 8544. Now let me run this. Yep, it's the second node just running right now, and I will try to connect to this node via the IPC. Now, on the second node, we did not create any accounts. I mean, these two nodes are independent of each other, not part of the same network yet until we connect them. So let me go ahead and create a new account for this. Now, if I go back to my node2 data, I see that there's a key store, which is with a new account. Okay, it created a new account. So I'm going to set that for this node, set the ether base as the first address that we created. So eth.accounts of 0. Now, if I check what is the Coinbase address of this node, it says the same account that I just created. Now, let me check if there is any peers, no peers. Now let's go ahead and connect these two nodes. So on the first node on the console, I'm going to run a command to get the enode address of this first node. So admin.nodeinfo.enode gives me the enode address, which is a really long hexadecimal ID, and then running in this IP address and listening to this port 30301. So I'm going to copy this entire enode address. And on the second node's console, I'm going to say paste and hit enter. So it's a true. Now, if I say admin.ps again, it has connected to my first node. Now, if I go back to my first node's console, I'll say admin.peers, I see that it has connected to my second node. So these two nodes are connected now, and they can together start mining network. Let me just start. If you look at this now, it's not mining anything. It is just starting the networking. So I'll go back and say miner.start. Now you see that it's committing the new mining network, and this is the first block has been created. So this was about creating a basic private network. Now smart contracts may be deployed and applications can start interacting with these nodes in the network. Let me stop this. Okay. Now, okay. Now, let's also create a private IPFS network with one node only. Now, IPFS is also a public peer-to-peer file storage and content delivery network, but we will be creating a private network with a single node. So again, as a prerequisite, we will need to download the IPFS client from this site, ipfs.io. Once done, let's go to the IPFS directory here. We see that there is nothing except for the swarm key that I just created. And then let me go back to my terminal and check if my IPFS is installed properly. So I'll say IPFS version, it's 0418. So the version we're going to use. And the next step is we say IPFS init. So this initiates an IPFS network on our virtual machine. So the default behavior is that it's going to initiate it's going to create a node on our VM and try to connect to the public IPFS network. So we will have to do certain steps to make it a private network. So it just created a peer on my VM, and this is the identity of that of my peer. So I'll have to make a note of this. Okay. Next step, I'm going to say remove all the bootstrap nodes from my configuration. So these are some of the default bootstrap nodes closer to my location. So my peer tries to connect to these bootstrap nodes to discover other peers and then try to store the files and interact with the network. So I just removed all these bootstrap nodes, and I'm going to have just my node as the bootstrap node. So this is the same peer that I just created here. And the next step, I'm going to instruct the IPFS client to force a private network. So I say export libp2p force pnet and IPFS daemon. So IPFS daemon is a background service that listens for any file uploads or a file download request on this peer. So I see that the API server is listening on this location on this port, and there's also a gateway server listening on this port 8080. Now on the second network, let me just second terminal, let me just say IPFS ID. So it just gave me the ID of the network that I just created, the peer that I just created, and also the public key and the other addresses and everything. Now let me try and upload a file. So I have a picture here called blockchain.jpg. So I'm going to try and upload this to the private network and see how it behaves. Copy. Okay. And say IPFS add. So it just added this file. So how it behaves is behind the scenes, the file is converted to its raw binary format, and then it is hashed using hash functions and then distributed across the network. So it uses what's called a decentralized or distributed hash tables. So every file, the address is actually a content address, what we call. So this hash is the hash of the content of this file. So if I were to upload the same file again from a different system, the IPFS will not load a new file or not upload a new file. It will just compute the hash and say that, okay, I already have this file on my system. So it kind of reduces the data duplication that way. Now I got this file. I'm going to copy this and try to, download this again on my system. So I say paste IPFS cat this file, download it as blockchain download.jpg. If I go back here, I see that this file has been downloaded. Yep, it's the same file that got downloaded here. So that was about the IPFS setting up of a private chain. So I'll leave this network as it is because I'll be needing this to demonstrate my KYC application. Now let's go back to the my Visual Studio Code IDE and take a quick look at the code and how the various components are configured. Now this Visual Studio IDE is running a combined project of Meteor and Truffle. So there are some directories. When we say create a new project in Truffle, it creates certain directories such as contracts, test, migrations, and build, and so on. So these are specific to the Truffle framework. Now, to show you the Solidity smart contracts, the smart contracts are in the contracts directory here. And this is a sample smart contract. So a typical smart contract, it's like a JavaScript like language, but also supports some of the object-oriented features such as inheritance, interfaces, abstractions, and so on. It also allows us to create libraries to have code reusability. So if I go to utility.sol, I have defined some of the enums and constants that I'll be using in my other smart contracts. Coming back to this smart contract, we see that a typical smart contract is similar to a class in an object-oriented language with state variables and the functions that operate on them. We have a constructor and we also have functions that operate that read or write on those state variables. Now there are also some constructs such as modifiers. Let me see, I'll show you modifier. Okay, right here. So these modifiers allow us to run a piece of code at the beginning or end of a function body. These are typically used to enforce some rules around accessibility, such as only users that are owners of a contract may use this function, etc. So in this function, renounce ownership, I use this modifier called only owner. So when this function runs, it first executes this modifier, says require this the sender or whoever's invoking this function to be the owner of this contract, else it will give out an error. Now, the smart contracts themselves are structured as per the functionality and some popular design patterns may be used to structure the contracts. Now, one thing is, it is to be noted that the blockchains are immutable by nature. So once smart contracts are deployed onto the blockchain, the code may not be modified for updates or defect fixes. Only the data, the underlying data can be updated or removed or anything, but the code itself becomes part of the blockchain state and it cannot be updated. So anytime we need a code change, a new contract will have to be deployed to replace the old one. So any data that is stored in the old contract is lost as a result. So for this reason, we employ a design pattern or a design concept called upgradable smart contracts, where the business logic and the data are separated into their own contracts. For example, we have a customer smart contract here, which has a bunch of functions to do various things, create customer, get profile, and so on. But the data actually resides in a contract called customer data, which does very limited functionalities and is actually inherited from data contract base. So this is nothing but a bunch of key pairs for the customer data. So anytime I have to change the logic of doing something on my customer contract, I don't have to worry about the data because the data is residing in the customer data contract. Now, also in our KYC application, each user gets his own contract. So any customer or auditor or a partner registering on the application gets his own customer data contract. So all his data is stored in this contract. So in the event that the user wishes to delete his data, he doesn't want to be part of this application anymore. All that is needed is to invoke this kill function, which will destroy the contract and destroy the data. So all these contracts are typically loosely coupled. Now let's quickly go and take a look at the development blockchain that we use called Ganesh. This is again provided by the Truffle framework, and it quickly spins up a blockchain node that we can use during our development and testing. So we can deploy our smart contracts, see how our application behaves with our smart contracts, and run some tests. So it's a very useful tool. You can see here that, let me restart this network here. Okay, so we can see here that the Ganesh has already pre-created some 10 accounts, externally owned accounts, and have allocated 100 ethers as balance to each of those that we had to do manually in the previous section. There is also sections for blocks. At this point, there is only a Genesis block, which is a block 0, and there are no transactions. And there is a window for logs where we can see what's going on in the network. To see the settings, this Ganesh blockchain node is listening on my local host in port number 7545, and the network ID is again specified as 5777. So what this basically does is, once I've started this Ganesh, it spins up a blockchain node, and then it allows me to interact with the underlying blockchain node pretty easily. So let's say Truffle console. Yeah. So in a moment we'll see that we'll get a prompt to interact with the Ganesh node. Now compiling, Truffle comes with inbuilt Solidity compiler. So all we have to do to compile our smart contracts is to go to our directory, the project directory, and say Truffle compile all. So it knows that it has to find the contracts in this directory, and it will start compiling the contract one by one. Let's take some time. Okay, the console also is ready, so we can take a look. Okay, it's compiling. And okay, once it's compiled, okay, while it's compiling, let's take a quick look at the Truffle config. It's the configuration file of the Truffle suite or Truffle framework. So it allows us to define networks. So one or more networks. So each network may be named. So here we've said development network, which is on this IP address and listening on this port, which is the development network. So I can, while migrating the contracts, I can just say that deploy to my development network, and it Truffle knows to deploy where to deploy the network. I can also configure other types of network like advanced or Ethereum's public test network, Robston, and some other configurations. And there are some settings for the compilers as well. I can specify that the code optimizer must be enabled, and there is also inbuilt test suite for smart contracts provided by Mocha. So I can configure that as well. If I go back to my build directory, I see that all the compiled contracts are stored here in the JSON format. Now let me open one of the compiled contracts. Got it. Now, two things in the compiled contract that are of interest here. One is what we call the ABI, which is the application binary interface in JSON format for the contract. Now this, yeah, here it starts as a JSON object. It's a array of objects. So the ABI describes the deployed contract and its functions and will be used by any external applications to interact with the contract. So ABI provides a context to the contract when it is already deployed. And then we have the bytecode. Oops. It's a pretty huge file. Yeah, so we also have the bytecode of the contract, which is like a low-level representation of the smart contract, and this bytecode will be stored on the Ethereum storage. Now, if we want to deploy these smart contracts onto our development network, we use the migration files provided by Truffle in the migrations directory. So in this file, we can easily specify what order the contracts needs to be deployed. For example, I can say that the network equals to development, first deploy my library files and then link those library files onto my contracts, and then start deploying the contracts in this order. First go from master store, then go for controller, then auditor data, and so on. So the Truffle knows in what order to deploy the contracts. Now let's go here and deploy the contracts onto our Ganache blockchain. So we could do that by saying Truffle migrate reset, which means if there are any existing contracts, just delete them and start over. Now, as I was mentioning, any transactions that changes the state of Ethereum blockchain is considered a transaction, any action, right? So now my contracts are being deployed by the Truffle deployer. So I see that each contract is deployed in a sequence. Deploy, and parallelly, when I go to Ganache, I should see that there are a lot of activities. And if I go back to the blocks section here, I see that there are so many new blocks and new transactions created. So there's many new transactions, the type contract creation. We see that all our contracts are deployed without any errors. So let's take a look at one of the contract deployment. Okay, so customer. So it has a transaction hash of this, and then the address of the newly created contract is this. So as I mentioned previously, even a smart contract when deployed has its own address. And the account that deployed this was this, which is the first account in my Ganache. The balance of this account is 99 ethers. And the gas used for this contract creation is about 6.5 million. It's one of the larger contracts. And the gas price that was paid was 20 gigaways. The total cost came up to 0.12 ethers. Now I can go back to my Truffle console and see if my contracts were deployed. I can basically interact with the contracts that was just created. So when I say customer address, I got the same address that was just created. Yeah. Now, this alternative way to see if the contract was deployed, I can also say, for example, I'll copy this address. So if I know the address of the contract and I want to interact with the underlying contract, I can do this. basically we see that it gave us all the ABI of the contract. Now, how do we integrate, how does our application, our front-end application or the API layer interact with the truffle or the Ethereum blockchain? So for that, we need to use certain packages. I'll show you a couple of them. The first one is the Web3 JS that I was talking about. This is a package, or this is a set of libraries that are used to interact with the Ethereum blockchain. And the Truffle contract provided by Truffle is kind of a wrapper around the Web3 JS, and it further kind of gives a better interface to interact with the underlying smart contracts. And we also have IPFS HTTP client, which is necessarily the IPFS APIs to interact with the IPFS network. So to take a look at one of our files. Imports API customer.js. Okay, so this is my application server-side code, which is actually running in Node environment, Node.js environment. So I can interact with the the blockchain network by using by initiating all the necessary packages like Web3 Truffle contract and IPFS client. And we also notice here that I will be using the customer JSON that was output as a result of the compiling of the smart contract. So this file has the ABIs which will be used by the Web3.js API to provide some context to interact with the smart contract. Now, I also set the providers for Web3, saying that my node is listening on this IP and this port. And for also IPFS client, I'm saying that this is the IP and the port. I've set the providers. And when I come here, I can easily invoke the smart contracts by doing this. A customer contract got deployed, then take that instance and call the save detail. So save detail is actually the smart contract method right here. So it's as easy as that, right? So as I was mentioning, any action that change the state of the blockchain is a transaction, and any reads are just calls. They don't consume any gas, so they just called calls. So I can show you that. Yeah. So here's where I'm not executing a transaction. I'm just making a database call to read some data from there. So I'm just doing a getProfile.call. And to download from IPFS, we just have to use the IPFS APIs to say, hey, IPFS cat readable stream. So it actually provides a stream which can be written onto the system, onto the file system. And also to upload, it's pretty simple as well. So all you have to do is IPFS.add a new file stream of that, and then it gets uploaded to the node that we have configured here. So it's pretty simple that way. Okay, now let's go ahead and interact from the application that we have running. Okay, this is not the one. Okay, so I already have my Meteor app running on this IP. So let me go back here. We also open the Ganesh. We take a quick snapshot of how many transactions are already there, how many blocks are already here. So we have about 17 blocks at this point. And yeah, these are the transactions. So let's see what happens now. So on my application, I'll start with registering a customer. So let's say Adam Andrews, username is Adam, password, and register. So we just sent a transaction. Now you can see that there's a new block created, block 18. And this is the transaction associated. This is the contract call, right? So let me copy this. And what we can essentially do is get a receipt of the transaction to see what really went on in that. So we come to the console and say, take this transaction and ask Web3 to give me the receipt of this transaction. So what we have here is the transaction receipt that we just executed. So it's a transaction hash. It's the hash of the block where this transaction was included. The block number is 18. The gas used for this customer registration and the cumulative gas. So as I was mentioning previously, every user that registers onto our application gets a new smart contract. So what we've seen here is there are two sub transactions. One is the main transaction that we invoke, and there is another smart contract creation transaction. So we essentially created a customer data smart contract on the fly. And this is the address of the new contract that we just created. So I'll say yeah. So what I'm essentially doing here is, from the controller contract, get me the user contract for this address, for the address that I just specified. Say enter, paste address. Sorry, this is address. So yeah, so this is the contract address for the customer item that I just created, and you can see that here as well. And the transaction receipt also has some topics, what we call the events. So the smart contracts or the Ethereum blockchain can raise events which can be monitored and consumed by the application. So the topic has the array of events and the the data associated with that, with those events. Okay, let me go back to my application and create an auditor. Register, auditor. Let me also pull up the hash. So we are still at block 18. I'm going to say red. Yep. So we got a new block 19, which is for registering this auditor. Now let me go back to my first window and log in as a customer. Now you may see that even though we interacted with blockchain, there is no new block created because we are just reading the information from blockchain. So there's no transaction created here as such. So I go to personal details. I see that the first name and last name are already pre-populated because it's being read from the blockchain. So I say date of birth, street, address 1, apartment 1, city Danbury, CP, country USA, zip code. At this point, I'm also going to upload some files. So I first upload the photograph of the customer, and then I upload the driver's license file, then I upload the passport, and then I finally upload the utility bill. So I say submit. Yep, a new block got created, block 20, which are all the transactions that I just sent. And also block 21. So you might wonder why there are two different transactions. So it so happens that there are some technical limitations where, a smart contract or transaction cannot accept too many parameters at once. So it's a practice to split the transaction into two to accommodate a large transaction. So let's also take a look at the IPFS here. So when I uploaded those 4 files, it also uploaded the files on the IPFS network, and these are the hashes, or these are the addresses of those files that is being recorded here. Now let me log in as the auditor. I see the submission. I come here and I see that the file, the customer's file is already downloaded. So when I come here, IPFS downloads, so it has the application's already downloaded the file from the IPFS network. Now, the auditor may say, download the driver's license, download the passport, download the utility bill. So we see here that all these files are being downloaded at this point. Oops. So the license got downloaded from IPFS, so did the passport. Now, okay, it got downloaded now. So now I can say that all the details have been verified. Oops, on the refresh. Okay, now I can say that all the details have been verified and approve the creation. Say submit. Now we should see some more transactions of this. So we have block number 23 now, which is approved. Yeah, all the data is being read from the blockchain. And I go back to my home page. It says token has been approved. So let me see if I can get the token from behind the scenes. Okay, now I'm going to go back to my console and run the command to interact with the underlying contracts. I see that the latest token file has been created. So from here on, it gets a little repetitive. The user interacts with the application, and new transactions are created, and new smart contracts are created on the fly in the application. So this brings me to the end of the demonstration. We were able to build, deploy, and interact with the Ethereum blockchain from our KYC application. I hope this was informative, and this is me, Harsha, signing off. Thank you very much for your time.
Alrighty, well, Criss, Suresh, Harsha, thank you so much. That was a great explanation of how to build a blockchain. I really appreciated the live demo. We appreciate your approach on this topic and for making this presentation for us. We have a few minutes for questions now, and please again direct me to those to me in the chat window. I'll ask our presenters. Our first question that we have is, what is the market readiness for blockchain?
As any other emerging technology, we have seen enough of hype around blockchain, right? With all the cryptocurrency market, there was quite a hype around blockchain that it can solve every other problem in the industry. We have seen that enough. And now, if we refer back to Gartner's hype cycle for emerging technologies, that hype period is over. Now, blockchain is getting into reality. Now, there were quite a lot of criticisms in the last 2 years, and it's good that most of these criticisms are getting addressed in terms of performance, interoperability between networks, and how to integrate with existing enterprise systems and all that. So it's taking shape. Things are getting addressed. And we see that quite a lot of enterprises have started exploring blockchain. So just to give some market statistics, out of 250 participants in a specific survey in 2017, there were 54% who participated or who are already doing blockchain projects. But last year, out of 600 plus participants, about 86% are already doing blockchain. So it's a significant increase in terms of number of enterprises looking into blockchain options and trying to integrate it into their enterprise systems. And if someone has not started, there's a right time to explore the potential use cases, start with proof of concepts, and then move on into pilots involving their business partners, vendors, suppliers, and then look at taking it into production. So it's pretty much ready. Of course, it has to be evaluated on a case-to-case basis. Blockchain is not a solution for every other problem in the industry. So the process evaluation is important. The right platform evaluation is important before we define the solution.
Great, thank you. Another question we have is, with products like Microsoft Azure actively advertising to have a working consortium blockchain up by one afternoon's amount of work, what are some missed opportunities with choosing an off-the-shelf solution like that versus building something from the ground up, as we saw on the demo earlier today?
We don't see as a missed opportunity, because even if you look at the offerings from Microsoft, SAP, and Oracle, it's a framework that integrates an open source platform or a blockchain platform with their enterprise ecosystem. It definitely helps in using those frameworks and templates offered by these vendors, because it saves time in terms of downloading individual open source components, installing them, and configuring them to a specific setup. But using those templates would be like one click of a button, and you can spin up a certain number of nodes and all that. It definitely saves time, but at the same time, you also need to have a clear understanding and knowledge on the open source platforms, because they work at the back end of any of these vendor frameworks.
Great, thank you for that explanation. One more question we have, and again, if you have any others, please go ahead and message them to me in the chat client. What is involved in adding or integrating blockchain into an already mature IT environment in an enterprise?
So it depends whether the existing enterprise system is a SAP or a Oracle system. So the first thing is what open source would be at the backend, the right to open source platform at the backend, and then look at the frameworks offered by these vendors on how integration can happen across either one system or multiple systems, how data has to flow across, and what are the internal access requests, external access requests, whether they want to extend it beyond borders and all that. So it's basically an evaluation process, which can be done with a couple of discovery sessions and then defining out the plan on how to go about.
Great. Well, we are about the end of the hour here. So again, I want to thank Criss, Suresh, and Harsha for their time and their well-constructed and informative presentation on how to build a blockchain. We look forward to seeing you on our upcoming episodes of the blockchain webinars. So audience, please don't forget to register for more webinars at htng.org/webinars. It is plural, so put the S in there. On that page, you'll also find our past webinars listed. You're welcome to review this recording and others in that series. You probably know some people that weren't able to make today's live presentation, and you are, of course, encouraged to direct your colleagues to access them there. If you have any questions or feedback, please do direct them to us here at workgroups@htng.org. Again, workgroups@htng.org. Thank you so much, and we'll see you guys on the next episode.